In this video, I'm going to show you how to create a calculated column in Desmos in order to linearize some data. In this case, the data has a hyperbolic suggested shape to the scatter plot. This data is actually pressure versus volume data. The volume is the vertical axis and the pressure is the horizontal axis. The pressure units are torrs and the volume units milliliters. And this data is collected from a real-life experiment. And we can see that this probably is not a good linear fit, but what we'll do is just double check that by inserting an expression that correlates these two, does a linear regression. So I'll do V1 and then the tilde to prompt regression, and then M P1 plus B. And sure enough, the R-squared value is 0.8765, which is quite low. And also with the line in place, it's very obvious that there's a curved shape that suggests we should do some further analysis. So I'm going to turn the best fit line off because it's not a very best fit. And the next thing I want to do is plot some points on here that correspond to the inverse of pressures on the horizontal axis and the volumes on the vertical axis, and they'll be inserted as an expression. So I'll click Add Item and an expression, and instead of an equation, I'm just going to put a set of points that are defined by the inverse of pressure and the volume. So I'll open a pair of parentheses, and then I'm going to just do 1 over P1 for my horizontal axis values, and then I'll put a comma, and then I'll do V1 for the vertical axis values and close my parentheses. And if you look over at the graph, you can see there is now a set of points, they're blue, that represents these coordinate pairs, but it's hard to see them showing any variability because of the scale of our axes. So that we'll have to change that later on. I'm going to take off the old values. And the next thing I'm going to do is I'm going to turn these values that I've just created, these points, into a table. So I'll click the little gear symbol up here, and where that expression is that establishes those coordinate pairs, I'm going to click the little table, and that converts those values into a table. X was the inverses of my pressures, so I'm going to put I1 as a label there, and the y-axis was my volumes. So I'm going to use V, but V1 is already taken, so I'm going to change this to V2. Now I'm going to change my scale to make this look a little bit better. I'll go to my graph settings, and my horizontal axis now, I'm going to make this range from about 0.001, just so the axis shows up. And going up to 1,000 is stupid because my largest horizontal axis value is under 0.005. So I'll just make that my upper limit, and it fits on there a lot more nicely. So now that I have that data in place and it's in a table, I can do regression on the values in the table. So I'll click Add Expression, and my vertical axis is now V2, the second set of volume data, tilde to prompt regression, and then M, and then I1, which is the inverse of the pressure values, and then plus B. And we can see that the R-squared value is much higher. We now have a slope that has some meaning, it relates the volumes to the inverses of pressure, and we can see that the vertical axis intercept is probably ignorable by the 5% rule that we use sometimes. Hope this helps.